Hello students, welcome to 1 to Infinity Tutoring. Today we are going to discuss about quantum numbers, which is a part of the topic quantum mechanical model of atom from the chapter structure of atom of class 11. In this particular class we are going to discuss about some introductory parts of the quantum numbers as well as their significances. So let's see. Quantum numbers are some significant numbers which can determine the position of an electron in any atom. As we have learned that in an atom there is a nucleus at the center which contains the protons and the neutrons carrying the positive charge by the charges carried by the protons itself, because the neutrons doesn't carry any charge, and the electrons are revolving around the nucleus in a particular orbit. So in an atom, a cell consists of subcells and a subcell consists of orbitals. We have to know these three terms: cell, subcell, and the orbitals. So what is a cell? Cell is the pathway where an electron moves around the nucleus of an atom. So what about the subcells? Yes, subcells are also pathways, but within the cell itself, in which the electron moves around the nucleus of an atom. So do not confuse between the two, cell and subcell. Subcells are the important, subcell are the smaller pathways within the cell itself, and whereas the orbitals are some mathematical functions which will describe the wave behavior of the atom. So each orbital can accommodate only two electrons which have opposite spins. For example, like a particular orbital, say 1s orbital, we can accommodate only two electrons in maximum which have opposite spins, either spin up or spin down, which will be later on discussed again. So now let's go to the next slide. Okay, what are the quantum numbers? So there are four quantum numbers. Number one, principal quantum number n, azimuthal quantum number L, magnetic quantum number m, and the spin quantum number s. These four quantum numbers are very important. Even though the concepts are very simple, many questions have been asked repeatedly in the NEET exam as well, and if we have time we will be discussing some questions from there. So let's see what are the informations that these four quantum numbers provided. So first we have to see, let's see the principal quantum number. Principal quantum number defines the cell. Yes, the cell that we have learned in class 10, K, L, M, N, so on, like that. These cells are defined by the principal quantum number. But here in class 11 it will not be denoted by K, L, M, N, but it will be denoted by 1, 2, 3, 4, which we will be seeing in writing the electronic configuration later on. And it also, the principal quantum number also determines the size of the orbital and energy of the orbital. And next, number 2, azimuthal quantum number L. It identifies the subcell and determines the shape of the orbital, right? So identifies the subcell, that subcell within the cell itself. It will be identifying the subcell and determines the shape of the orbital. So for L equals to 1, there is only one s orbital. How? And for L equals to 1, 3 p orbitals. For L equals to 0, it is there will be only one s orbital, and for L equals to 1, there will be 3 p orbitals, and for L equals to 2, there will be 5 d orbitals. So this magnetic quantum number, azimuthal quantum number, principal quantum number and spin quantum number, they are all interrelated. We have to know that. So there are twice L plus 1 orbitals of each type in a subcell. For a particular subcell, there is twice L plus 1, and as L signifies the subcell itself, so we have to keep in mind that the value of L can never be equal to or greater than the principal quantum number n. So please keep it in mind. So n should always greater than L. So there are twice L plus 1. When L is equals to 0, that is 2 into 0 plus 1, that is 1. Only one s orbital will be there. For L equals to 1, there will be 3 p orbitals, that is 2 into 1 plus 1, that is 3. It will be ranging from plus 1 to minus 1 to plus 1, minus 1, 0 and plus 1. That gives the 3p orbitals, px, py, pz. And likewise 5d orbitals, minus 2, minus 1, 0, plus 1, plus 2 likewise. Okay. And the number 3 magnetic quantum number m designates the orientation of the orbital. It has been explained above already, because the value of L gives the number of what? M itself. Okay. For example, here also it is given for a given value of L, M has twice L plus 1 values. Okay, and the last quantum number S refers to the orientation of the spin of the electron. Okay, there are 2 spins which an electron can have, either plus half or minus half. But an electron cannot have the 2 itself. Either it can have one of the 2, plus half or maybe minus half. Plus half, spin up, spin down, like that. For a particular orbital, let's say 2s orbital, in 2s orbital we can accommodate only 2 electrons, as we have seen, we have also mentioned earlier. So these 2 electrons can have one spin particularly, either plus 1 and plus half or minus half, spin up or spin down. So we can take another example also. P, one of the p orbital, let's take px. In px also we can accommodate only 2 electrons in maximum. So each electron can either have one of the 2 spins, like plus half or minus half, spin up, spin down. Okay, so these are the 4 quantum numbers that we have discussed today. Thank you, and we will be discussing more about this and the application of these quantum numbers in writing the electron configuration in the next class. Thank you very much.